Hi guys, welcome back to my channel Pirai Academy. In this series of data structure playlist, today we are going to see about code implementation of singly linked list. If you haven't saw the logical implementation of singly linked list, go back and watch that video. It is a previous video of this playlist. And here I am going to teach in a C++ language. If you want a Java or Python code, you can go and search in the description. I'll be giving those codes. Okay. Now see here. Let's get started. So initially I'll be taking a structure. Okay, this structure going to store the node members, which means the data and the next address value. Okay, so if you want to use the class, you may use, this is C++, you can either use structure, or you can also use class. If you are going for the Java or Python, you can use a class to define this. In class, you have to put the data members as data and next address value, and in the constructor you can initialize those things, right? Okay, now class singly linked list. So this class is going to be much more important because it will be containing the ADT and it will be containing the linked list. Rather, this class or this structure only going to contain the node, data and its next address. That's it. Okay, now in this private I will be just taking the node star to the head. Okay, while the constructor is executed, the head will be pointed to the null pointer. Okay, now here comes the functionalities. First functionality is insert at beginning. In this you will be giving some data in a parameter, and see here, when we are doing a insert at beginning, what we will be doing, we will be creating a new node for that given data and making the new node next pointing towards the head pointer, and now the head will be pointing as a new node. That's it. So this is going to be the insert at beginning, right? In the logical implementation itself I have told this. Okay, now let's get into the next functionality, insert at end. So here also you will be giving some data as a parameter. So first I will be creating a new node, okay, by using the data, and the next, if the head is equal to null pointer, then what it signifies, there is nothing. So there itself you can insert that new node, which means head is equal to that new node. Else what should I do? I will be taking a temporary value as head, and I will be going up to what? Up to the temp next is not equal to null pointer. Okay, I'm going to temp next is not equal to null pointer. I will be going on unless this is satisfied, this condition is satisfied. Up to that I will be going to the next value. Okay, after this, after executing this while loop, I will be standing somewhere at a node at which the temp next will be surely equal to null pointer, which is the last node. Okay, at that point I'll be doing what? Temp next is equal to new node. That's it. Yes. Okay, now insert at index. So here you will be getting two parameters, one is index and another one is data. Now I want to check whether the index is a negative. If it is so, it is invalid. And then I want to check whether index is equal to 0, which means it is inserted beginning. So I'll be just calling that inserted beginning data. This function itself, inserted beginning function. Okay, I don't want to worry about anything. Okay, now node star temp is equal to head, or else I want to take that node star temp is equal to head, and I'll be moving up to where? Up to, I want to make sure, I will be initializing I is equal to 0, and I want to make sure a condition called temp should not equal to null pointer, as well as I should be less than index -1, which means if the index is something like 5, I want to go for 4 steps only. If the index is 2, then I want to go for only 1 step only, like that. Okay, now for that I will be going again, I will be going to the next node for this temp. Okay, now after this, if my temp is equal to null pointer, which means I cannot insert, which means index out of range. Can I understand this? See here, if there are only of 5 linked list nodes, but I want to insert at the 6th node, at the 6th index, then I cannot insert it because we only have 4 index, up to 4 index. We didn't even have 5th index. Then how come I can insert at the 6th index? Can you understand this? So that's the case here. I also taught this case in the drawing explanation itself, right? That logical implementation. Now here comes, if the temp is not equal to null pointer, then what should I do? I will be just creating a new node first, okay? And that new node next will be pointing to the temps next, which means I already told you, right? So let me draw here so that you can understand this clearly. If I have 1 and 2, okay? So here is my temp. If I want to insert a 2 next to the temp, then I will be making the 3 to point to temps next, and temp next will be pointing towards 3, so that I can now tell you that 1, 3, 2 is my linked list. Can you understand this? Okay. Now see here. That's what I have done here also. Temp next is equal to new node. That's it. Okay. So please try to visualize it in your brain, because when you are going with the linked list and trees, visualization going to help you. Fine. Okay. Now delete at beginning. So now we are going for the deletion operations. So delete at beginning. So for this, I want to check whether the head is equal to null pointer. If it is so, I want to just return what? List is empty and return that itself. Okay. Else what should I do? I'll be taking the temp variable, temporary variable is equal to the head pointer, and head pointer will be moving to its next node. Head will be moving to its next node, and I'll be at last delete the temp value. I will delete the temp node, okay, so that I will be get rid of the first value. Which means deletion at the beginning. Yes. Now deletion at the head. Deletion at the end. So if the head is equal to null pointer, then that stuff I can tell you that list is empty and return. If not, if head next is equal to null pointer, which means I am head. I don't have anything next to me, which means the linked list have only one node. Then that is going to be the end. That is going to be the beginning. Can you understand this? At that scenario, what should I do? I will be just deleting the head and making the head as null pointer. That's it. Can you understand this? So what is this case? This case called, there is only one node, and that node is a beginning and that node is a end. Can you understand this? Okay. Now, if not, if these two conditions are failed, then what should I do? I'll be going to this part, like I'll be making the temp as head. Okay. Then while temp next is not equal to null pointer, which means, see here, I must stand where I must stand to the last node's front, which means I want to stand at some node which its next node is the last node. What is the property of last node? Last node next will be null pointer. So I can tell that I want to stand at some node to which its next value will be node, but it's the next value going to be null pointer. Please try to understand this. Yes. Okay. Up to that, I want to go with the temporary variable. Okay. To the next values. At last, what should I do? I should be deleting the temps next. That's it. And temps next will be pointing to null pointer, as I already told in the logical explanation itself. Okay. Now delete at index. So this is going to be somewhat difficult. Okay. At index, they will be given in the parameter. Now, if the head is again equal to null pointer, then that's how I can tell you that list is empty. Then if the index is less than 0, I will be telling that it is an invalid index. If the index is equal to 0, then I can tell you that it is deleted beginning. Now here comes. Now I want to take the temp as head initially. Okay. And up to which I want to go? Up to the deletion nodes front I want to go, which means I want to go for index -1 steps. index minus 1 steps. For example, if I want to delete the node at the second index, then I want to go for only one step. I want to stand at the first index so that I can cut the linkage to the second node, and I'll be just making a linkage to the third node so that the second index will be deleted. Can you understand this? Okay, but if we don't have any index at that particular point, which means the length of the linked list is 4, so that the last index value will be what? 3. But I want to delete the fifth index value. We don't have any fifth index value, right? So at that point we should not delete, right? So this loop will be going for, like, there are two conditions. One is temp should not be equal to null pointer, as well as I should be less than index minus 1. Then only this statement will be executed. Okay. Now, if temp is equal to null pointer, or temp next is equal to null pointer, which means it is out of range, we cannot delete that because there is no node existing. There is no node existing. Can you understand this? Yes. Now, node star node to delete is equal to temp next, which means if we have next node value, then I should be taking a node to be deleted like temps next. Okay. Now, temps next is equal to node to deletes next, which means I will be connecting my linkage to the next node's next node value, so that a linkage will be given to the next node value. Can you understand this? Yes. Now, delete the node to delete. That's it. So here there's a traverse function to just traverse among the linked list and just printing the values of the linked list. That's it. Okay. For this it is simple. Up to the temp is not equal to null pointer. Temp is initially equal to head, and up to the temp is not equal to the null pointer, I want to go what? I want to print the temps data, and I want to go with the temp is equal to temps next. I will be going to the one by one like that. Okay. And in the destructor, I will be going from the head up to the null value. I will be going from the head up to the next value up to the null pointer, and I will be just deleting all the nodes on that. That's it. Okay. And this is going to be your menu driven program. Let me execute this so that we can understand this clearly. Okay. So first, let me do insert at beginning. Okay. So what is the data? Let me 3. Again insert at beginning. Again 2. Again insert at beginning. Again 10. So now if I print, it should be like what? 10 to 3, right? So for print it is 7. So 10 to 3 and null. Can I understand this? Yes. Now if I do insert at end, and for example data should be 12, and again if I traverse this here, 10 to 3 12 and null. Can I understand this? Yes. Now if I do 3 and then some index like 2, and I will be inserting 5, then if I traverse this and print it, it will be 10 to 5 3 12. Yes. Now if I insert at some index called 10, okay, so and the data is going to be 19, index out of range, we cannot insert that, right? Now if I go with delete at beginning, yes, 12 is deleted, so 12 is the, see here, delete at beginning, sorry, delete at end. 5 means delete at end. Okay. So what is the end value? It is 12. 12 is deleted. Can I understand this? If I put 4, which means delete at beginning, which means I will be deleting 10. So 10 is deleted, right? Yes, 10 is deleted. Now if I go with delete at index 6, then I want to give the index number, right? So let me delete at second index. 3 is deleted. Yes. Now if I go and traverse it, see here 2 and 5 are remaining. So let me put 5, again 5. If I put again 5, which means delete at end, list is empty. Can I understand this? Yes. So this is the whole implementation of singly linked list. And if you clearly understand the singly linked list, you can able to implement doubly linked list and also the circular linked list. Okay, so that's it for this entire video. If you like this video, just like this video and subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are going for the problem solving. And if you have any doubts in this code implementation, just comment below. I will be commenting it out answer, or I'll be putting a separate video on it. Thank you.